Okay, so this video is about finding inconsistent or no solution and dependent infinitely many solution with our equations. So we're going to find inconsistent and dependent equations. So we start it the same way. You're going to pick two of the rows and we're going to try and cancel them. So I'm going to start with the bottom two and we're going to pick a letter to get rid of. And the reason I'm picking this is the y's. The y's look beautiful because they're already ready to go. So if I add this up, they cancel, giving me negative 4x plus 2z equals 2. And so now I pick the top one. And I'm going to pick the bottom one as well. Remember, you have to pick all three to use them. All right, and so on this bottom one, I'm just going to multiply it by 2. That way the y's will match. We're getting rid of the y's first. So this is negative 2x minus 2y plus 6z equals 4. Equals 5. So let's make sure it's all lined up. All right, that's a plus. So positive, positive, minus, positive, yep, and then negative, negative, positive, negative. And if you look at this, what happens? That's right, things cancel. So anytime you get this situation where all your variables are disappearing, that's when we get our inconsistent or dependent. And so you're just going to look at them and ask yourself, is it true or false? If it's false, it's inconsistent. If it's true, it's dependent. So does 0 equal 9? No, that is false. So since it is false, we know it is no solution. The system is inconsistent. So you can either say no solution or you can say inconsistent. They both go together. So if they say solve, you would say no solution. If they say is it inconsistent or dependent, you would say inconsistent. So that's it. So now let's check it in our calculator. So I've got it all plugged in. And we hit enter. And there it is. And see that last row? How it says 0, 0, 0, 1? That last row is where we're going to get our horrible situation. So if it's consistent, we're getting a solution. You'll see that we have those diagonal ones. Everything works great. When you get that last row of zeros, it's not good. So the calculator gave us 0, 0, 0, 1. And so if you remember, that's x, y, and z. So what it's saying is our left side of the equation is 0. The right side is 1. That is false. See? So it will give you a false statement as well, telling you it is inconsistent. Okay, so obviously the next one is, you guessed it, dependent. So let's try this one now. So looking at it, I can already see that the top and the bottom, these two have a multiple of 2. So let's just start with those two. So I'm going to multiply the top one by 2. That gives me 2x plus 8y minus 2z equals 6. Negative 2x minus 8y plus 2z equals negative 6. So now when you solve them, you see you get 0 equals 0. That is true. So that means we have a solution. It is infinitely many solutions. So we're getting a line basically is our point. So if you think about all three planes intersecting, they could be the same exact plane, giving you an infinite number of planar solutions. Or you could have a line where all three pieces of paper, like planes, meet. But it's infinitely many solutions. This is a dependent equation. And there you have it. And so if we check this in the calculator, you'll see that the bottom row is all zeros. So same exact thing that we got here is what the calculator will say as well. Okay, so let's do one more purely by calculator. So on this one we have 2, negative 3, and you notice we're missing a z. So we put a 0 for z. So again, it's x, y, and z. And then it's 4, negative 5. Oop, there's no y. Negative 5 and 10. And then there's no x, negative 12, 10, and negative 4. So if you were going to solve these, you'd first cancel off the x and use it with the y. It would work out perfectly, but we have our calculator, so we're going to use that instead. So I've already entered that matrix C into our calculator, and it gives us this. So you see that last row is all zeros. All zeros mean we have 0 equals 0. So we have 0, 0, 0, 0. And so that gives us, you got it, it's dependent. So infinitely many solutions. Okay, so now what we're going to actually do, though, since it's dependent, is we're going to write a solution set. So we need an x, y, and z for our answer. And they're going to be in terms. So you want to do is pick a letter, any letter that you want to use. And so a lot of people like x, so we'll start with x. So that means we need to solve y for x and z for x. So if you look at your first equation, you can see that we have an equation that is in terms of x and y. So if we were to solve this, so negative 3y equals negative 2x plus 4, you get y equals 2/3 x minus 4/3. That is now a formula for our y. And our second equation has x and z. So what we're doing is solving each letter for x, or in terms of x. So now we move that over. So it's negative 5z equals negative 4x plus 10. Divide by negative 5. And so z equals 4/5 x minus 2. And so there you have it. This is now an equation that we can use to plug in any x value, which would give us every single solution to this system. Now there's a little bit quicker way to do this. You already have your calculator that solved your system for you. So if you go back and look at it, it gives us this. Now you think, oh, I don't want to use decimals. Well, if you hit math and number 1 fraction and hit enter, it converts them all to fractions. So you look at the first one, it says x minus 5/4z equals 5/2, and x minus 5/6 equals 1/3. So if we fill that in, we get 1, 0, negative 5/4 and 5/2, 0, 1, negative 5/6 and 1/3. This is our x, y, and z. And so you'll notice it's already giving us stuff that we can solve. You see it now? Okay, so I'm going to erase dependent and infinity solutions, so now we're giving a solution set instead. So this would be x minus 5/4 z equals 5/2. So if you solve for x, you get 5/4 z minus 5/2. And the other equation is y minus 5/6 z equals 1/3. So solving that one over gives you it. So you can also do this in terms of z. See, so each of them is in terms of z. I'm going to erase this and put it because I ran out of room. Just shrink it. So we had y minus 5/6 z equals 1/3, which gives us, shrink it again. 5 doesn't like shrinking. So we would get y equals 5/6 z equals 1/3. Let's move this all down. So if you look at it now, you can see that x is this value. So 5/4 z minus 5/2. And 5/6 z, that's a plus 5/2, plus 1/3. And so this allows you to have two different equations. See, different ways. You just have to pick a letter and solve for it. So you could go back and I'm going to solve everything for y. That would be horrible on these. Actually, it's not that bad. But you'd have it all in terms of y. But your calculator is the quickest way. If you just rewrite all three equations, the bottom one says it's dependent. The other two will allow you to put them in terms of z, because you already have your x and your y. It's just a quick move over. So you could even see it as 5/4 z plus 5/2 and 5/6 z plus 1/3. It's just the opposite sign of this because you will move it over. So sometimes you will be asked to write infinitely many solutions. Sometimes you will be asked to write dependent system. And then sometimes they're going to ask you, that's a star, to give an equation, and any three of these would work. The calculator is the quickest. So if you use your calculator, it tells you right there it's dependent because it's all 0 equals 0. That's our last equation. And then you can use these two to find your x and your y. All right, thank you.